بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. These are exercises review about chapter 2. So the graph here is given of a function f, and we need to find each of these limits or explain why it doesn't exist. So the limit of f of x when x approaches 2 from the right. Well, this is x. This is the number 2 here, and we need to approach 2 from the right and look to the function. Where is the curve? This is the graph of the function. It's going where? To negative infinity. So the limit is negative infinity. The limit of f of x when x approaches negative 3 from the right. 0, negative 1, negative 2, negative 3. This is negative 3. Approach negative 3 from the right. What happens to the function? This is the curve, f of x, approaching what? Approaching 0. So the limit is 0. The limit of f of x when x approaches negative 3 in general. We have seen from the right. Now, if x approaches negative 3 from the left, the function goes to this number, which is negative 2. So the limit from the right is not equal to the limit from the left. This means that this limit does not exist. Since the limit when x approaches negative 3 from the right equals negative 2 of f of x, of course, and this is not equal to 0, which is the limit of f of x when x approaches negative 3 from the right. So from the right, we found it 0. From the left, it's negative 2. So the limit does not exist. The limit of f of x when x approaches 4. 1, 2, 3, 4. This is 4. Approach 4 from the right. The function approaches this number, which is 2. Approach 4 from the left. The function also approaches 2. So the limit of f of x when x approaches 4 is 2. What about when x approaches 0? Approach 0 from the right. The function goes to infinity. Approach 0 from the left. The function also goes to infinity. So I can say that the limit of f of x when x approaches 0 is infinity. X approaches 2 from the left. Well, this is 2. I have a mistake here. Yeah, when x approaches 2 from the right, the function goes like this. So it approaches 3. So this is not correct. This is 3. While when x approaches 2 from the left, the function approaches negative infinity. So that's a mistake. When x approaches 2 from the left, yeah, it approaches negative infinity. What if x approaches infinity? If x approaches infinity, the function approaches this number, which is 1, 2, 3, 4. So f of x approaches 4. And when x approaches negative infinity, the function goes here, approaches negative 1. State the equation of the horizontal asymptotes. Horizontal asymptotes are found using limits at infinity. So when x approaches infinity, f of x approaches 4, this means that the line y equals to 4 is a horizontal asymptote. And limit when x approaches negative infinity of the function is negative 1, this means that the line y equals negative 1 is also a horizontal asymptote. State the equations of the vertical asymptotes. Vertical asymptotes, infinite limits. So any infinite limit. Yeah, we have infinite limit here when x approaches 0. So the line x equals to 0 is a vertical asymptote. And also we have negative infinity here. So the line x equals to 2 is a vertical asymptote. At what numbers is f discontinuous? Explain. So the line x equals to 0, x equals to 2, vertical asymptotes, y equals 4, y equals -1, vertical asymptotes. The function is not continuous at this number, -3. Function is not continuous at -3. And the reason, because the limit from the right, when x approaches -3, or let us say the limit does not exist. The limit when x approaches -3, as we have seen, does not exist. So this means that the function is not continuous at -3. Also, the function is not continuous at 0 because it's not defined. The function is not defined at 0. That's why we have a vertical asymptote. Also, it's not continuous at 2. Okay, at 2. Notice that the function is defined at 2. F of 2 is 3. But it's not continuous because the limit does not exist, because the limit from the right is not equal to the limit from the left. So at 2, the limit of f of x when x approaches 2 does not exist. So this means that the function is not continuous at 2, because from the right of 2 it's a 3, from the left of 2 it's -infinity. What else? Also at this number 2, 3, at 4. At 4 the function is not continuous. And what is the reason? Because the limit of f of x when x approaches 4 is not equal to f of 4. Because the limit when x approaches 4 is 2. Actually, yeah, is 2. But f of 4 is 1. Okay. So the limit is 2. F of 4 is 1. Remember that the function is continuous when limit of f of x as x approaches a equals f of a. This is the definition of continuity. And the function will be continuous at a if it is defined at a, so we can find f of a. If the limit exists, limit from the right equals limit from the left, and if the limit equals f of a, 3 conditions. Okay, so you see at -3 and 2 the limit does not exist, so the function is not continuous. At 0 the function is not defined, so it's not continuous. At 4 the limit exists, f of 4 exists, defined, if defined at 4, but the limit is not equal to f of 4, so the function is not continuous at 4 because the limit is not equal to f of 4. Sketch the graph of a function f that satisfies all of the following conditions. As x approaches -infinity, the function approaches -2. So this means that the line y equals to -2 is a horizontal asymptote. When as x approaches infinity, y approaches 0. So this means that the line y equals to 0 is a horizontal asymptote. As x approaches -3, the limit approaches infinity. And this means that the line x equals to -3 is a vertical asymptote. And the function goes to infinity, to the right and to the left. Now, as x approaches 3 from the left, the function goes to -infinity. So x equals to 3 is also a vertical asymptote. Remember, Infinite limits, vertical asymptotes. Limits at infinity, horizontal asymptotes. So x approaches 3 from the left. The function approaches negative infinity. So I can connect these two like this. And as x approaches 3 from the right, the function approaches 2. So 3 from the right, the function approaches 2. So as x approaches 3 from the right, the function approaches the number 2. And f is continuous from the right at 3. So if f is continuous from the right at 3, this means that this point is closed. So the limit of f of x when x approaches 3 from the right would be equal to f of 3, which is in this case 2. So this is a graph of a function that satisfies all of these conditions. So for the function to be continuous at right, limit x approaches a from the right should be equal to f of a. Left, a from the left, limit of f of x should be equal to f of a. Find the limit. Let us replace x by 0. 0 plus 0 is 0. Cosine 0 is 1. So the limit is 1. Let us replace x by 3. 9 minus 9 is 0. 9 plus 6 minus 3 is 12. So the limit is 0 of 12 when we replace x by 3. So the answer is 0. The limit is 0 because 0 over 12 is 0. Now replace x by negative 3. Negative 3 squared is 9. 9 minus 9 is 0. And negative 3 squared in the denominator is 9. 2 times negative 3 minus 6 minus 3, that's 0. So I'll get 0 over 0. Once we get 0 over 0, we try to factor or multiply by the conjugate. We can factor here because x squared minus 9 can be factored using the formula u squared minus v squared is u minus v times u plus v. So it's x minus 3 times x plus 3. And x squared plus 2x minus 3 can be factored. X squared x times x. And we search for two numbers. Their product is negative 3 and their sum is 2. How about positive 3 and negative 1? Product negative 3, sum is 2. So now we can cancel x plus 3 with x plus 3. And I can replace x by negative 3. Negative 3 minus 3 is negative 6. And negative 3 minus 1 is negative 4. So the limit is 3 over 2. Now if I replace x by 1, 1 minus 9 is negative 8. 1 plus 2, 3 minus 3, 0. So the limit here is positive or negative infinity. But which one of them? I need to replace x by 1.1. So 1.1 square minus 9 would be negative. And 1.1 square plus 2 times 1.1 minus 3 would be a positive number. Negative over positive is negative. So the sign of infinity here is negative. And this limit goes to negative infinity. If I replace r by 9, square root of 9 is 3. 9 minus 9 is 0. Anything over 0 would be plus or minus infinity. Will it be plus or minus infinity here? The numerator is always positive. Square root of r is positive because r is 9 or 9.1 or 8.9, okay, around 9, so it's positive. R minus 9 to the power 4, this is also always positive because this is power 4. So even if you choose R 8.9 and get a negative number here, when you raise it to power 4, it would be positive. So positive or over positive is positive. So the sign of this quantity is always positive. So the answer is positive infinity. Here, when V approaches 4 from the right, this means we choose a number greater than 4. And if we choose 4.1, then 4 minus 4.1 is negative. And we know that. So when x approaches 4 from the right, I have 4 minus v over absolute value of 4 minus v would be equal to negative 4 plus v if 4 minus v is less than 0, or if 4 is less than v. So if v is greater than 4, absolute value of 4 minus v would be negative 4 plus v. And the difference between 4 minus v and negative 4 plus v is a negative sign. You can take negative as a common factor. So I'll have negative 1 here. So you can cancel these two and get a negative 1. And the limit of negative 1 would be negative 1. So this limit is negative 1. Let me replace r by negative 1. Negative 1 squared is 1. Minus 3 times negative 1 is plus 3. Minus 4, so I have 0 in the numerator. Negative 1 squared is 1 times 4, I have 4. Minus 1 minus 3, that's also 0. So I have 0 over 0. So we try to factor or to multiply by the conjugate when there is a square root. There is no square root, so we need to factor. R times R. Search for two numbers, their product is negative 4 and their sum is negative 3. Negative 4 and positive 1. Product negative 4, sum negative 3. 4r squared plus r minus 3. Well, here, negative 1 is a 0 of the numerator and the denominator because we got 0 over 0. So I must have r plus 1 here. If I have r plus 1 here, this is 4r squared, so I'll have 4r here. And this is negative 3, so I must have negative, I must have negative 3. So 1 times what gives negative 3? 1 times negative 3. So negative 3 times 1 is negative 3. That's good. And 4r, negative 3r would be 1r. So that's the factored form of the denominator. We can see that we can cancel these two and we can replace r, not x, by negative 1. So negative 1 minus 4 is negative 5. And negative 4 minus 3 is negative 7. So the answer is 5 over 7. If I replace t by 5, 5 plus 4 is 9. Square root of 9 is 3. 3 minus 3 is 0. 5 minus 5 is 0. 0 over 0. Try to factor or to multiply by the conjugate. Now here I multiply by the conjugate because there is a square root. Well, the conjugate, you change the negative in between to plus because again, we need to use the difference of two squares formula. If you multiply u minus v times u plus v, you get u square minus v square. And when you square, you get rid of the square root. So let us multiply, and we multiply fractions like this. A times c over b times d. So if when you multiply the numerator times the numerator, u minus v times u plus v will give you u square, which is 9, minus v square, which is t plus 4. And here I'll have t minus 5 times 3 plus square root of t plus 4. Now, in the numerator, I have 9 minus t minus 4. 9 minus t minus 4. And 9 minus 4 is 5. So I have 5 minus t in the numerator and t minus 5 in the denominator. Well, 5 minus t and t minus 5 are the same, except with a negative 1. So if you divide them, you get negative 1. So the limit would be negative 1 over this. Now I can replace t by 5. Now I can replace t by 5. And the answer would be I have negative 1 in the numerator and 3 plus 5 plus 4 is 9, square root of 9 is 3, 3 plus 3, 3 plus 3 is 6. So that's the limit. As x approaches negative infinity or infinity, we take the highest power of the numerator and the highest power of the denominator, and we neglect all the other terms. So here I will deal only with the square root of x squared and neglect the 9. And here I'll take 2x and neglect the 6, the negative 6. Now, there is no equality here. So this equals to limit when x approaches negative infinity of square root of x squared is absolute value of x. But x goes to negative infinity. So absolute value of x would be negative x if x is less than 0, which is the case here. So this would be limit when x approaches negative infinity of negative x, because x is negative, over 2x. Now x cancels with x, and the answer would be negative 1 over 2. So that's the limit. X goes to negative infinity, so we deal with the highest powers in the numerator and in the denominator, and we forget all other terms. So negative 1 over negative 3, the limit is 1 over 3. Well, here, of course, if we have something like this, if you replace x by negative infinity, you will have infinity over infinity. And also here, infinity over infinity. But here, if you replace x by infinity, this will give you infinity minus infinity. And infinity minus infinity is indeterminate form. So I need to change it to infinity over infinity. So I need to multiply by the conjugate. And now when we multiply by the conjugates, multiply the numerators, you get u squared minus v squared. So the square root will disappear and we have negative x squared. Now x squared cancels with x squared. And now if you replace x by infinity, you have infinity over infinity. Because in the denominator, you have infinity plus infinity, which is infinity. So now we use our method and we take the highest power in the numerator and the highest power in the denominator. Notice that square root of x squared will give you absolute value of x. And you already have x outside the root. So you have to take into consideration these two terms and forget about square root of 4x plus 1. But x goes to infinity. So absolute value of x would be equal to x if x is positive, which is the case here. So I'll have 4x and x plus x would be 2x. X cancels with x and 4 over 2 is 2, and that would be the limit. To find the limit of the function f of x as x approaches 1, let us find the limit. of 2x minus 1 as x approaches 1, which is this one. 2 times 1, 2 minus 1, 1. What about the limit of x squared, which is this one? When x approaches 1, 1 square is 1. So by squeeze theorem, there is a theorem, squeeze theorem, that says if this limit is 1 and this limit is 1, then limit of f of x when x approaches 1 is also 1. Okay, this is called the squeeze theorem. Evaluate each limit if it exists. X approaches 0 from the right. If x approaches 0 from the right, which means x is greater than 0. So this would be the definition of the function. 3 minus 0 is 3. So that's the limit. When x approaches 0 from the left, what would be the definition? X is less than 0. It would be square root of negative x. If you replace x by 0, you get square root of negative 0, square root of 0, which is 0. Limit of f of x as x approaches 0 does not exist, because the limit from the right is not equal to the limit from the left. Limit as x approaches 3 from the left. As x approaches 3 from the left, x is less than 3. X is less than 3, so we will use this definition. 3 minus x. Replace x by 3, you get 0. From the right of 3, x is greater than 3. This is the definition, x minus 3 all square. So that's the function. Replace x by 3. 3 minus 3 is 0. 0 square is 0. So the limit of f of x as x approaches 3 is 0. Where is f discontinuous? It's not continuous at 0 because the limit does not exist at 0. And it is continuous at 3 because the limit exists and it's equal to f of 3. F of 3, by the way, is 0. So it's continuous at 0, at 3, not continuous at 0. Let me check here. X is less than 0, negative 1, negative 2. So a negative would be positive, so it would be continuous here. This is square root continuous in this interval. 3 minus x is a straight line, it's continuous in this interval. This is a parabola, continuous in this interval. So f of x is continuous everywhere except at 0. Sketch the graph of f. Well, I have 3 parts. To the left of 0, the graph of square root of negative x. So to the left of 0, I need to graph this function. At 0, it is 0. And the equality is not there. So I'll put an open circle here. At negative 1, square root of 1 is 1. At negative 4, negative 4 is 4, and square root of negative 4, square root of 4 is 2. So this would be the graph of this function in this interval. Now, from 0 to 3, I need to graph 3 minus x. So from 0, 1, 2, 3 to here, I need to graph the function 3 minus x, which is a straight line. At 0, 3 minus 0, it's a 3. So it's here. And it's closed because the equality sign is here at 0. While at 3, the equality sign is not there. At 3, 3 minus 3 is 0, but the equality sign is not there. So I'll put an open circle. And this is the graph of this line from 0 to 3. Greater than 3, I have to sketch this function. x minus 3 all square. And I know that this is a parabola similar to x square shifted 3 units to the right. So the graph is like this. So if you replace x by 3, it would be 0. So now I close this one because it's with the parabola. And at 4, it is 1. And I have the graph of the parabola. Okay, it doesn't go like this. It goes like this. Okay, this is the graph of the parabola. And now this point is closed. So this is the graph of this function. And you can see that this function is not continuous at 0 only, but it is continuous everywhere else. And you can see also that the domain of this function is set of all real numbers, but the range is from 0 to infinity, because the y-axis from 0 starts to infinity. Find the slope of the tangent line to the curve. Well, the slope of the tangent line at the point 2 is f prime of 2. That's the slope at 2. And by definition, this is limit of, let me use this definition, h approaches 0, f of 2 plus h minus f of 2 over h. This is one of the definitions of f prime of 2. Remember, f prime of a has two definitions. Either it is limit when x approaches a, f of x minus f of a over x minus a, or limit as h approaches 0, f of a plus h minus f of a over h. So I'll use this definition, the second one here. You can use the first, it's okay, it will give you the same answer. Now what is f of 2 plus h? I replace x by 2 plus h minus f of 2. What is f of 2? I replace x by 2, or I just use the one here, because of course it would be 1 over h. Let us expand. What is the square of 2 plus h? 4 plus 4h plus h squared minus 1. Well, 9 minus 1 is 8. So I can just erase this one and write 8 here over h. I cannot subtract because I have to multiply 2 first. So 8 minus 2 times 4 is 8. Minus 2 times 4h is negative 8h. Negative 2 times h squared over h. 8 minus 8 is 0. And I can take h as a common factor. So I have negative 8 minus 2h. I just took h as a common factor. Of course, you can take negative 2 if you like. Now h cancels with h. And when I replace h by 0, I get negative 8. So the slope of the tangent line is negative 8. This is m, the slope of the tangent line. Find an equation of this tangent line. Well, for the equation of this tangent line, we use y minus f of a equals f prime of a, which is the slope, times x minus a. So f of a is 1 because the point is 2, 1. F prime of a, we found it's negative 8. X minus 2, a is 2. So that's the equation of the tangent line. If you want, you can write it negative 8x minus 8 times minus 2, positive 16 plus 1, positive 17. Find equations of the tangent lines to this curve at the points with coordinates 0 and negative 1, with x coordinates 0 and negative 1. So he is asking about the equations, two equations of the tangent lines. at a is 0 and at a negative 1. So here we will find two equations, all right? And I have the possibility now to find f prime of 0 and f prime of negative 1. So I will use this definition twice, or I can find f prime of a in general and then use it to replace a by 0 and negative 1. And I'll do that, okay? And I'll use here the first definition, which is this one, okay? So limit x approaches a, f of x minus f of a over x minus a. I'll take x minus a outside, and f of x is this function minus f of a, which is 2 over 1 minus 3a. And this would be equal to, now I have two fractions and I need to subtract them using the formula 1 minus 3x times 1 minus 3a. You subtract a over b minus c over d using this formula, ad minus bc. So 2 times 1 minus 3a will give you 2 minus 6a, and minus 2 times 1 is negative 2, and minus 2 times minus 3x is positive 6x. 2 cancels with 2. Okay. So I have limit as x approaches a of 1 over x minus a times. Here I can take negative 6 as a common factor. So I will have a minus x. So let me take 6 as a common factor, not the negative. So I'll have negative a plus x. Why I needed negative a plus x? Because I have here x minus a, which is also negative a plus x. So I can cancel them together. So these two can be cancelled. And now I can replace x by a. I have 6 in the numerator. And here I have 1 minus 3x. And here I have, but I replace it by a, so I have 1 minus 3a. And here I have also 1 minus 3a, so it would be 1 minus 3a squared. So this is f prime of a in general. Now let us use first that a is 0. And let us find the equation of the tangent line when a is 0. So it's y minus f of 0 equals f prime of 0 x minus 0. So I need f of 0 and f prime of 0. Well, f of 0, I find it from here. 2 over 1 minus 0, so it's 2. So f of 0 is 2. F prime of 0, I find it from here, because this is f prime of a. So I replace a by 0, so it would be 6 over 1, which is 6, times x minus 0, or just x, and the equation would be 6x plus 2. Now when a is negative 1, so find equations of the tangent lines at 0 and negative 1. So I'll have the equation y minus f of negative 1 equals f prime at negative 1 of x minus minus 1 or plus 1. Now I need to find f of negative 1. To find f of negative 1, I use this definition. So f of negative 1 would be 2 over 1 minus 3 times negative 1, so it would be 1 plus 3, which is 4. So it is half. So f of negative 1 is half. What about f prime of negative 1? I find it from here. So f prime of negative 1 would be 6 over 1 minus 3 times negative 1. So 1 plus 3, 4. 4 square is 16. So 6 over 16 or 3 over 8. So the slope at negative 1 is 3 over 8 times x plus 1. And I can leave it like this, or I can take everything to the right hand side. So 3 over 8 plus half, it would be 7 over 8. So this is the equation of the tangent line at a equals negative 1. Find the derivative using the definition of derivative. Well, the definition of derivative, f prime x equals limits f of x plus h minus f of x over h when h approaches 0. What is f of x plus h? I have a fraction, so I'll take 1 over h outside. F of x plus h is 2 over x plus h square. I replace x by x plus h minus f of x, which is 2 over x squared. And I need to subtract these two fractions. So I use the above formula. So I multiply the denominators, and 2 times x squared minus 2 times x plus h squared. Let me expand. I have x squared plus 2hx plus h squared. When I expand x plus h to the power 2. So I'll have 2x squared minus, let me multiply by negative 2, 2x squared minus 2 times 2, negative 4hx, negative 2 times h squared. These two cancels. And in the denominator, I have h times x squared times x plus h all square. Well, this is h written here, so either I write it here or there. So leave it there. Now, what should we do? As usual, I take h as a common factor from the numerator. So I have negative 4x minus 2h. And I have this h times x squared times x plus h all square. H can be cancelled with h. And finally, I can replace h by 0. So I'll have negative 4x in the numerator. This will go. And here, h is 0, so I'll have x squared times x squared. X squared times x squared is x to the power 4. X to the power 4 minus 1, because you subtract the powers, you have x to the power 3. So that's the answer. That's the derivative. He asked about the domain of f prime. Well, this is f prime, so the domain of f prime are real numbers except the 0 of the denominator, which is 0. Another function. We need f prime. F prime of t is the limit when h approaches 0 of f of t plus h, which is, I'll take 1 over h also out. F of t over h would be 1 over square root of t plus h plus 1. I replace t by t plus h minus f of t over h, which I took outside. Again, I need to subtract these two fractions using the formula. So t plus 1 times t plus h plus 1. And in the numerator, 1 times t plus 1 minus t plus h plus 1. Now, if I replace h by 0, I'll get 0 over 0. So what to do? I need to multiply by the conjugate, which is square root plus square root. Nice. So I'll have limit h approaches 0, 1 over h times. Now what happens if you multiply these two fractions? You multiply the numerator times the numerator. U minus v times u plus v will be u square minus v square over all of this. I use parentheses here because I have two terms. Well, here I have t plus 1. Let me write it by another color. T plus 1 minus t minus h minus 1. So t cancels with t and 1 cancels with 1. And h would be cancelled with h. So let me write 1 over h, and I have negative h in the numerator, and all of this in the denominator. H cancels with h. And now I can replace h by 0, so I have negative 1 in the numerator, and square root of t plus 1 times square root of t plus 1, because h would be 0, will give me t plus 1. Okay, square root of x times square root of x is just x. And the second term, this is okay. Here it has an h. H would be 0. So it's square root of t plus 1 plus the square root of t plus 1. This would be 2 times square root of t plus 1. So this would be the answer. You can write it if you like, negative 1 over 2 times t plus 1 to the power 3 over 2, because power 1 and power half will give you power 3 over 2. What is the domain? He is asking about the domain. Well, this is f prime in front of us, and the domain of f prime would be all real numbers except negative 1, because it will make the denominator 0, but not only negative 1. Because we have a square root, it is 1 over 2, so it's the square root of t plus 1. So this domain is not correct. It's not just a denominator, we have a root in the denominator. So t plus 1 should be greater than or equal to 0. So t should be greater than or equal to negative 1. But negative 1 is not accepted because it will make the denominator 0. So let us remove the equality sign. So the domain would be from negative 1 open to infinity. And now if you replace t by any number in this interval, 0, 1, whatever, then the function, the derivative would be defined. So this is the domain of the derivative. Find the asymptotes of this graph and use them to sketch the graph. Well, let us start by the vertical asymptotes. For the vertical asymptote, we said we find limits, infinite limits. We search for infinite limits. Negative 3 makes the denominator 0. So it's a candidate for a vertical asymptote. So let us find the limit of this function when x approaches negative 3 from the right. Well, it will give you for 7 over 0. So it's either positive or negative infinity. So which one? Greater than negative 3, this is negative 3, this is negative 2. I'll choose negative 2.9. So 4 minus negative 2.9 would be a positive number over 3 minus 2.9 would be a positive number. Okay, so if you replace x by negative 2.9, this would be positive and this would be positive, so I'll have infinity. While if I approach negative 3 from the left, I also get 7 over 0. So either the limit is infinity or negative infinity. But if I replace x by a number less than negative 0.3, which is negative 3, sorry, which is negative 3.1. So 3 minus 3.1 would be negative, while 4 minus minus plus would be positive. So the answer would be negative infinity. So there is a vertical asymptote, which is x equals to negative 3. This is a vertical asymptote, and we know the behavior of the function to the right and to the left of this asymptote. Also, what about the horizontal asymptote? The horizontal asymptote, we find the limit as x approaches infinity. Either infinity or negative infinity, we have to find the two. But actually here, there is no difference between positive or negative infinity because we usually take the highest power and forget about everything else. So x goes with x, and the limit whether x goes to infinity or negative infinity is negative 1. So I have one horizontal asymptote, which is the line y equals negative 1. So I can sketch the graph now of this function. The line y equals to negative 1 is a horizontal asymptote. The line x equals to negative 3 is a vertical asymptote. As x approaches negative 3 from the right, the function goes to infinity. So the graph would be like this. It will intersect the y-axis somewhere. So I can find the y-intercept. You put x0, you get 4 over 3. So the y-intercept is here. So the graph would be like this. Also, it will intersect the x-axis. I can find the x-intercept. To find the x-intercept, I put y0. Cross multiplication, this is 0 over 1. You get 4 minus x equals 0, or x equals 4. Or immediately, the fraction would be 0 if the numerator is 0. So you just find the 0 of the numerator, which is 4. So 1, 2, 3, 4, so it will pass by this point. And this y-intercept, and then it will go up with the asymptote, and here also it will reach the horizontal asymptote, approach the horizontal asymptote. So this is the graph to the right of the vertical asymptote. To the left of the vertical asymptote, as x approaches negative 3, the function approaches negative infinity. Okay, and it must go by the horizontal asymptote. Well, there is a possibility that the graph could intersect the horizontal asymptote. So to find out whether this graph intersects the horizontal asymptote or not, I put the two equations equal to each other. So this is the function, and the horizontal asymptote is y equals negative 1. So let me put 4 minus x over x plus 3, or 3 plus x, equals negative 1 over 1. Cross multiplication, so 4 minus x would be equal to negative x minus 3, because you multiply x and 3 by negative 1. Now negative x cancels with negative x because you can add x to both sides, and 4 minus 3 is not possible. So there is no intersection point between the graph and the horizontal asymptote. This is the last question. The graph of f is shown. State which with reason the numbers at which f is not differentiable. 2, 3, 4. It is not differentiable at -4 because f is not continuous at -4. It's not differentiable at -1 because there is a corner. It's not differentiable at 2 because f is not continuous or not defined. Okay, it's not defined, and that's why it's not continuous. Finally, at 5, at 5 here, at this point, if you sketch a tangent line, you will find that you have a vertical tangent line. So this function is not differentiable at 1, 2, 3, 4 numbers, and it's not continuous at -4 and 2 only, but it's continuous at -1 and 5. This is the end of this review. I hope you benefit from it and you review it again and again.